So what are some of these natural background radiations that people are exposed to, right? So the thorium and uranium, they are omnipresent in rocks and minerals here. And the half-life of this thorium-232 and uranium-238 are of similar magnitude compared to the age of the Earth. So really long-lasting here. That means you need to have the age of the Earth for it to decay half of its concentration. So this decay, right, will be stabilized into something called the lead-206 species here, or we call it the uranium-238 series here, and also the lead-208. So the isotope of lead-206, right? And the lead-208 is under the thorium-232 series. So potassium-40 has a half-life of 1.25 billion years and decays to calcium-40 here. You might see that, right? There's a 40 potassium-40 to calcium-40. What is the change here? The mass number remains the same, but the proton number has increased by 1 from potassium to calcium, right? So it's still a decay. Now, where do we find potassium? Banana and other drinks. So about 0.012% of the natural potassium exists as potassium-40, which is a tiny amount, but you can't neglect that the rest are more of potassium-39 here. The cosmic radiations occur when you have an interaction of these cosmic rays with the gases of the atmosphere here, right? And 90% of these cosmic rays are like protons, these alpha particles, your 4,2 helium 2+, your positrons and other heavier elements, possibly lead. So in the regards for radiation and health hazards here, you have got your ionizing radiations that interaction with matter along the travel path, right? You form hydroxy radicals from water, your OH dot, right? And then of course we have a direct image on biomolecules like in our DNA, right? So that's why we need to have some supplements. They call it the radical scavenger, right? So that it doesn't decay your DNA or alter it. Now you also have alpha particles that have very high ionization efficiency, but they have low penetration depth. See a difference between penetration. Gamma rays penetrate the most, it's most powerful, so it's very harmful. When your ray has high ionization, but they do not penetrate, so it's less harmful, but they still ionize. So these are the highly toxic as well, right, when ingested. So what I'm saying is, right, you can't penetrate, but if you open up and then let it go in, then it's very, very harmful. So beta particles have penetration depth of 1 cm, just very short 1 cm into tissue, and have a medium ionization efficiency. But gamma rays are the one with low ionization efficiency, but can easily penetrate through the organs and tissues, including our bones as well. So if you recall this character from Street Fighter here, Blanca, yeah, or even Hulk, right? They have pulled through your gamma ray radiations. Now for radioactive decay, alpha decay is the emission of the alpha particles, again your helium-42, which is just a nucleus, right? Some of it you have seen is a helium-42 2+. For me, it's not a big difference. It is typical for elements with atomic number greater than 83, right? So beta decay is the conversion of a neutron into a proton and the emission of an electron and an antineutrino. So you have to do a balancing of the equation. Once again, beta particle, you convert a neutron, which is a 1,0 particle, into a electron and an antineutrino. So this occurs in elements of a high neutron to proton ratio, right? Means you have a lot of neutron compared to proton here, possibly more than 2:1 ratio. So beta plus decay is a conversion of a proton into a neutron and the emission of a positron. And positron is more physics, but positron simply is a positive charged electron. Does it make sense to you? That means you have a similar mass of an electron, but then it's plus charge, okay? Plus a neutrino. So this occurs in elements of low neutron to proton ratio, right? An element will be a hydrogen 1,1, right? Low neutron to proton ratio. So electron capture is the inverse of beta decay. Protons absorb the inner orbiting electron and becomes a neutron. Okay, and there is this emission of a neutrino gamma ray. So it is not a form of decay, as it doesn't affect the atomic ray and mass number, but it occurs with other forms of decay. So it is have a discrete energy, quantum energy level, right? Discrete. You can't vary by it's quantized, and this is the characteristic of the nuclide or the gamma spectroscopy, because it's characteristic to what kind of decay it is. So in terms of activity, Becquerel BQ is an SI unit for one nuclear disintegration per second. Here you might want to check out what is a new SI unit system here, because there was a revamp last year. So absorb dose, we use gray, like Jean Gray, GY as 1 joule of absorbed energy per kilogram of tissue, while 1 RAD is a radiations absorbed per dose. Okay, so 1 gray, 1 GY is equivalent to 100 RAD in medicine. Next definition is the effective dose. This is the multiplication of absorbed dose with radiation's weighting factor. So the radiation weighting factor consider, right, the tissue and the type of radiations, and the SI unit is CVAD. Okay, CVAD is SV, and REM is the Röntgen equivalent for man. And when I say man, it doesn't mean male, but human. Okay, man. Röntgen equivalent for man. So next, we talk about VOCs, asbestos, and others. Okay, so example of these volatile organic compounds is formaldehyde. Formaldehyde is a preservative for dead bodies here. When you want to preserve the corpse to pay your last tribute with the funeral, this is the smell of formaldehyde. So this comes from materials that contain formaldehyde-based resins such as pressed wood. You want to make sure it doesn't decay, right? The wood here found in plywood or Eurofoam installations in the construction industry, or in building a new home or cabinet. So this is used as a fabric dye, carpets, synthetic fibers, but it really causes headaches, dizziness, and concentration difficulties. So therefore, it'd be wise that after a home renovation, so you move to a new place here, let it cool, let the wind blow, let the smell goes off before you move in here. So it could be as dangerous as causing cancer. So asbestos, as we mentioned previously, that it is a natural occurring fibrous silicate mineral trapped and sequestered in the lungs here, and these are particles of asbestos causes the lung cancer and asbestosis, used frequently until about in the 1990s in building construction industry here. But some countries still use, and of course companies use it illegally, so it's because it's odorless, you might succumb to this disease only when the bad thing is done. So some other sources of indoor pollution includes the open bottles with cleaning fluids or paints, thinners, glues, or correction fluid. Those smell. Again, it's all about dosage, but you remember those are toxic, so don't smell too much and get addicted to it. Wall paints, even those are water-based latex paints, right? No. These are indoor pollutants. Overheated cooking oil. When you overheat the oil, the acrolein, as well as the pesticides and insecticides, these are also indoor pollutants. And with that, it brings it to the end of the indoor pollutants. So next part, we'll go on to look at the units and scales. Cheers.